Could you could you start your talk?
Thank you. Thank you all for coming to this last session. I would like to start by thanking the organizing committee for doing an excellent job having us here. It was a fantastic event. Thank you all. I'm Pavlos Christoforou. I'm the CEO of Point9 and one of the founders. And today, especially given it's the last session, I will tell you a story. So let's start right at the beginning. This is the radio amateur club of my high school. So that's like nearly 40 years ago, 35. This is a ISO valve transceiver, ham. You could communicate all over the world. And when we were 12 years old, me and my friend Yannis, we discovered that I come from a small island in the Mediterranean, quite isolated. We could actually talk to people and talk to us back. You will get the microphone, you turn the antenna, and you just call, "Hi, I'm here," like you would do on Twitter these days. And people will answer from all over the world. And it was very exciting because suddenly we communicate with people everywhere. That was before there was even the concept of the internet. Or maybe there was. And then soon after, the personal computer revolution started. So we had all these small ZX Spectrum. You can see I'm a dinosaur. I mean, maybe you've never seen these things before. But what was really amazing was at some point we realized that as long as we could get this to send ones and zeros across the world, suddenly the solution space opened up. So anything we could digitize, we could send it across. And at the beginning, we had no idea of what the repercussions of this. So what we did, of course, was to start putting them together, and the first thing we could send was actually characters. So we had protocols like what was called like the RTTY, which is a radio teletype. So you could actually type. You could actually type, and they would be transmitted on the other side and would be decoded. And immediately after, people realized, well, if we can send a sentence, we can send a page. And if we can send a page, we can start sending images, like with ASCII characters. I'm sure you've seen ASCII art before. So suddenly, was all this excitement. We will spend weeks putting electronics together and computers and get it up and running and turn our antenna, and suddenly we get the first reception. And what do you think is the first thing we ever saw? That's like in the early 80s. It was a cat. Like a cat, ladies and gentlemen. After 20 years of development of bandwidth, we're still sending cats, which was exciting, but it looked like that. But the point I want to make here, which was really amazing, was that what digitalization plus communication opened up a space that we could not see the possibilities at the time. It still plays out. We got the internet. We started with protocols like IRC. Then we have Twitter, Facebook, YouTube, and it's still playing out. It's when you get, sometimes in history, when you get certain things coming together, certain possibilities, and the solution space opens up, then only imagination is the limit. So from then on, 20 years later, I find myself working in climate research, processing, at the time, gigabytes of data. So we got data from the satellites coming in, lots of them. And then we also got lots of data coming from the numerical models we're running. So we're running these global simulation models. Each country had their own. Japan had their own, the UK, and we all got together, and you got all this data which we needed to, sorry about that, we needed to get together and somehow make sense of. And that's when Python came in. So the problem we were facing is that we have lots of data and not enough tools to actually analyze them and answer questions. Same problem was faced by Yannis, co-founder of Point9, who was my friend during the ham radio years, in a big tier 1 bank, that they had lots of data, derivatives data traded, and they couldn't really make much sense of them. It was difficult. So at that time, we found Python. Yeah, we will write code in Fortran, we'll write code in C, so it will run fast, still do. But what Python gave us at the time was the numeric extensions, which allowed us to load huge arrays in Python and have the expressivity of Python applied to it to start really making sense of the data. And that's a very big thing, and I believe that was the beginning of Python's orientation towards data analysis, which now has made Python one of the important, if not the prominent tool in data analysis and machine learning. The other thing that it gave us was expressivity. We were already facing difficult problems. The physics were hard enough. We didn't need to worry about monoids and other things and stuff in computer science. We just needed to think hard about the problem, and we just needed tools that could actually let us do our job quickly and efficiently. So we have things like list comprehensions of what didn't exist when we were using Python version 1.4. But we also had things like this, b equals a times 3. And what's really beautiful about it is that a could be a number 2, or it could be a three-dimensional tensor, which is what we were using in climate research, and it will still work without much thinking. It will just take 3 and multiply every single element of the array. And what's really cool about it, it didn't matter whether it was integer, whether it was low precision float, whether it was high precision float, it will just work. If you're a Go fan, try to do this for any type of integer or real or anything else. It gets really ugly really quickly. Okay, here we had the benefit of operator overloading, but even without that, it wasn't so bad. This is a very basically an algebra relationship, like the transpose of the product of two matrices is the product of the transpose of the two matrices. It's not so bad. And we don't require a DSL. This is just Python syntax. Everybody who knows Python will understand at least the syntax. It's clear. And that's a major thing. But also Python gave us an ecosystem. At the time, now it's standard that languages have good standard libraries. It wasn't the case at the beginning. So Python gave us an ecosystem and a community of great engineers. So we could not only find a good library, but we could actually contact the authors, and usually was the best person to help us and form a relationship, as we did with Marc André, who is a core Python developer, and we've been working together for 12 years. So after all these experiences, on one hand, Jan is explaining to us what the problems the big banks were facing at the global scale, and us with our experience of Linux, web technologies, and Python, we decided to leverage our knowledge and get together to form Point 9 that was going to work in the data space for the big banks, big financial institutions. What we do is we are focusing on trade processing, which I can explain to details. Please stop me. I will go into more detail if you want, but it's essentially a data processing and management problem. In other words, we have data coming from a large number of systems in various formats, various protocols. It could be FTP, it could be HTTP, it could be APIs, it could be MQ series. It could be JSON, it could be mostly CSV, that's what we're facing. It could be PDFs that we need to parse. We need to parse all this data, store them somehow in efficient ways, and then validate them, enrich them, and then disseminate them to all kinds of other third parties in a timely manner. And again, Python is really good at that. A typical workflow will involve validate, enrich, and transform. To keep it very simple, we will connect via multiple communication protocols to all kinds of systems. It could be via internet, it could be via proprietary lines. Lots of data parsing, making sense of it. It has to be fast, it has to be robust. Lots of exceptions, lots of undocumented formats. Again, one great benefit of Python, and sorry about this. Oh, okay. All right. Okay. So this is a typical flow of information. I just put it here. It's too busy just to show you the complexity we're facing. We have order management systems, fund managers, compliance systems, market data providers like Bloomberg, service providers, prime brokers, payment systems, SWIFT network, just to reason about the business types around this is already a very hard problem. And again, what Python, the impact of Python on our business was that it uniquely allowed us. It's Linux, so you're gonna have trouble. Okay. Oh. Can we? I don't think I would be able to on this machine. Sorry about that. Okay. The problems of using old Linux versions, I suppose. So what Python uniquely allowed us to do is to focus a lot more our constrained resources on actually solving our clients' problems instead of the implementation, much more than any other alternative would allow. And this is still the case, even today, with Python. So I would think that that was our leverage. That is the leverage that Python is giving us. But there was a missing ingredient. Yeah, we could solve the problems, we could code the problems. What we couldn't do is where are we going to run the code and where are we going to store the code? That was a big problem for us. We couldn't provision terabytes of data. We couldn't provision hundreds of CPUs. It would be too expensive for us. We're a small company. We're just starting up. Our competitors are big global institutions. So Amazon came in, and they basically gave us APIs to run infrastructures. And that's, I think, the next big thing. So what the cloud has done, it has transformed infrastructure provision into a coding exercise. And Python is a really good language for them. We have things like Ansible, which we use a lot, Boto, all the APIs are exposed already in Python, and this is a big deal. Like when I started, where we got communication together with digitalization, what we're having now is this transformation of what used to be physical processes into APIs. It's a big deal. It has increased the solution space, practically infinite. And of course, inexpensive storage is quite important too. And cloud is just the beginning. And like the marriage of telecommunication and digitalization, we're just now beginning to see the possibilities. So initially, we just had servers or just storage. And then, of course, we have new things coming up like serverless, like Amazon Lambda, because we no longer need to worry too much about the infrastructure. It's all programmable. We might as well create a function and just run it. And this is, again, the beginning of what we are seeing as the marriage of coding with APIs essentially driving physical infrastructures. To give you an idea of what we are facing as one of the biggest challenges in this industry, it is uncertainty. To summarize it, we do not currently know what questions will be asked to answer 6 to 12 months from today. Regulation changes, market changes. So how do you architect a solution if you don't know what the questions are? I mean, the first thing you will do normally when you architect the data warehouse is ask, what questions do you want to answer the data warehouse? But we don't know. They change all the time. And we still need to do something. So our solution now is to gather as much raw data as possible, like we used to do in climate research. We get all the satellite data, store it, and then figure out how to process them. get everything. Presumably, we have all the data, at least this is all the data we have anyway, and we can think about the answers later on. So again, we need tools that are quick to use, quick to deploy, quick to analyze this data. Python is in its own here, on its own. We need massive processing power to run calculations on all this data. Fits the cloud model very well. You can switch it on, switch it off, no problem. It allows us to answer ad hoc questions that before were not possible. Either you needed to provision, I don't know, Oracle power enough to be able to run this every single second, or you couldn't just do it on a... Need to keep an eye on this. And as it turns out, this is extremely useful to any data-driven organization of all sizes. So by 2017, we're pretty comfortable with our processes, with our technology, with our clients. And we're about to relax a little bit when we met with the MUFG team in London, and they basically told us, well, cute work, guys. Do you want a real problem to solve? And they gave us enough problems for a couple of lifetimes. So we're talking about much bigger scale, global institution, very, very interesting problems at the scale level. Many more businesses or types of data to make sense of. What do they mean? What do the clients want? What does the management want? How are these affect the business? So we have scope, bigger scope, like we have data cleansing, deduplication at scale, consolidation, normalization, lots of statistical techniques we can apply, not necessarily machine learning, but also machine learning. User interfaces challenges. How do you answer quickly? I mean, user interface here is a generic term. So we have all this data, and there is a question, how do we get to the question, and how do we present it as efficiently as possible to the end user, which usually is the client? And process challenges. This is actually very interesting, especially for me, personally, because what we are facing here is a challenge of composition. We all have this approach, or would like to have approach to write composable code, whatever the language. We like to be able to compose code, whether it's object orientation via mixin, whether it is, I don't know, Golang via structs, or however you want to do it. The challenge, it's nice to be able to compose your code, but here we're facing a higher, more interesting problem. Not only we need to compose at the code level, we need to compose at the process level with human beings that perhaps are doing a couple of manual processes on Excel spreadsheet, and we need that step to remain manual for whatever reasons, but we need to incorporate that into a system. So how do you do it efficiently? We don't know yet exactly what's the best solution, but I feel, again, Python is what's going to help us a lot here. And I would like to close with this, where basically I started in a way, that transforming rigid physical processes into programmable systems and APIs is an extraordinary development. And cloud is just the beginning, and we're going to be seeing the repercussions as we go along. Mitsubishi is seeing the same thing and willing to move in this direction. We are extremely grateful and happy to be working with them, to have this vision. Of course, we are interested in this kind of problems at this scale. Please talk to us. Thank you all.
Okay, thank you for your talk. Okay, do you have any question and comments? Okay.
Hi, thanks for the presentation. So, generic question around AWS. You mentioned a few functions, you mentioned Lambda.
Yes.
Can you tell us a bit more about which are the services that you use the most, especially in the context of massive amount of data?
Sure. Very, very good question, because it's actually something we're discussing right now, and I will explain why. Initially, we took a conservative approach. We will be using Amazon services that we could replicate outside Amazon. So VMs, So it was whether it was Amazon or outside on our own, didn't really matter. Storage, file storage, but then you have things like S3, which is a global storage that you can just throw lots of objects on it and you can process them later. So that was our initial setup, and maybe DNS services like Route 53 and simple email services and SQN, simple queue services, but still things we knew we could replicate outside. At some point, Amazon is layering more and more useful services. So now we are at the position where we made a decision to go for it, because a competitor can come in and use them all and will just move faster than us. So Redshift is very important. We have not yet deployed anything on Redshift, but we are looking at it seriously. On the management side, we have played a little bit with Amazon Glue, which is an ETL tool. It just came out. We don't think it's yet at the point where it's we're happy with it to deploy it. Same with Lambda, by the way. We're having problems with exception management in Lambda. We don't really know exactly what's happening. It's a little bit scary. Maybe it's just about us getting used to it. So Lambda is not out there, but we are certainly looking in that direction as well. Okay, we're using Postgres at scale. And we're using a lot SQLite on fast file systems. SQLite is like the Swiss Army knife in the for us at least. So we will deploy ephemeral but very fast storage and write lots and lots of data on SQLite, which is quite fast. It's actually easy to scale as well because it fits the multi-processing model of Python. So one database can be read by many processes and parallelize calculation.
Other question and comment? Nothing? Okay, thank you very much.
Thank you all. Thanks a lot.